Good afternoon. This is Dr. Madhusudana Reddy, PBR with Kavali. This video session for thought we take the second sem WE students. The subject is the design of photovoltaic system. I entered into the first unit containing the PV cells. Already covered 4 video sessions. Okay, so now this is the 5th video session. I'll continue with this video session as the effect of temperature on PV cell characteristics. A little bit already I introduced in the earlier video session also. When it changes, dVOC by dt, how it affected, okay? How much of percentage will be vary? Minus 0.1 millivolts per degree Kelvin. Already explained thoroughly the derivation part for that formula also. dVOC by dt equal to VOC minus VGO plus MnVT divided by T. So these are all the characteristics of the material. So we can determine these parameters. But what I want to explain in this class, these are all the parameters not depends on the characteristics, which depends on the temperature variation. Immediately will affect on the coefficient of variation. For example, temperature coefficient effect on ISC, the temperature coefficient of VOC, temperature coefficient of PM. These are all the represented with letters A, alpha. For example, see here, this is about the temperature coefficient of ISC, which is represented with alpha I. This is about the temperature coefficient of VOC, it is represented with alpha V. This is the temperature coefficient of P maximum, it is represented with. See here, in the data sheet, they are mentioned that alpha I is equal to plus 0.045%. When it changes, what is the change in the current when temperature changes? For example, actually these the values are represented at 25 degrees centigrade Kelvin. Okay, 25 degrees centigrade, not Kelvin, 25 degrees centigrade. Okay, these values, even this value also minus 0.34 and this value minus 0.47, change in the value. But when you change the temperature, at this temperature, what is the ISC actually? What is the ISC actually? The value of the ISC at actually is 8.99 amperes. But when the temperature changes, at these values, when the temperature changes, this ISC is not 8.99, which will change something. Okay? That we want to determine here. So let us try to understand the temperature coefficient better by doing some examples. So here temperature coefficient of ISC is alpha I, temperature coefficient of VOC is alpha B, temperature coefficient of peak power is alpha P. For example, we'll consider here ISC 0.045% varies and VOC 0.34% minus and alpha P minus 0.47. Okay, so let me see here how, what is that formula? I want to calculate the ISC at 40 degrees centigrade. Okay. What is that formula? Okay. First of all, what is the ISC at 45 degrees centigrade? Is already mentioned on the nameplate. Is already mentioned on the nameplate. So this is the value 8. Okay. So this value is 8.99 amperes. Plus, we want to evaluate delta I. So this value you want to calculate with delta. What is that formula? I'll explain later. Similarly, VOC 40 degrees centigrade I already on data sheet we know that VOC at 45 degrees centigrade. Now we want to evaluate this value delta. What is the change in voltage? Similarly, PM at 40 degrees centigrade. So I want to calculate. You know that what is the PM at 25 degrees centigrade on nameplate details? Okay, so 240 watts. Here, see 240, and this is 298 degree Kelvin, 25 degrees centigrade. So these are the values: 8.9 amperes and 36.72 volts. This is about 36.72 volts. This is about 8.99 amperes, and this is about 240 watts. Yes or no? And I want to evaluate delta I. I want to evaluate delta V. I want to evaluate delta V. Then I can able to calculate what is the current at 40 degrees centigrade, what is the voltage at 40 degrees centigrade, open circuit. What is the maximum power at 40 degrees centigrade? Okay, fine. So that we want to evaluate. These are all the values are mentioned here. So now I want to calculate those things. Delta I, how to evaluate this delta I and delta V and delta P. See here. What is the formula for this? Delta. So delta I is equal to formula ISC 25 degrees centigrade plus alpha I into ISC 45 degrees centigrade into delta T divided by 100. So you'll pick up this ISC is the common 1 plus alpha I into delta T by 100. So this is about the. I want to evaluate ISC at 40 degrees centigrade. What is ISC at for 25? 8.99 into 1 plus alpha I already given in nameplates. Given in nameplate. Plus 0.045. 0.045 and into delta T. What is the delta T? Change in temperature. 40 minus 25 divided by 100. You'll see 8.9968 amperes. So what is the change in 0.0068 amperes. 0.0068 amperes. This much. This much. How much change? 0. Change is 0.0068 amperes. How much change? 0.0068 amperes. You can understood that when the temperature increases, the short circuit current increases, but how much increases? 0.0068 amperes increases for 40 degrees centigrade. If temperature changes, this 0.0068 is also changes to other values. Okay, fine. You understood that? Then you'll come back here. Now, that is the explanation here. What? Now we'll come back to this VOC. How you are obtaining this VOC? Then VOC changes. Let me go for it. Let me go for it. What is the formula for this? We'll come back here. All these explanations are related to that. Okay, related to that. Now we'll go to this. VOC 25 plus delta V. What is the delta V? So VOC at 25 degrees centigrade plus alpha V into VOC at 25 degrees centigrade into delta T 100. We'll take as this is common 1 plus alpha V into delta T by 100. So therefore, what is the value of this? Already you know from their details. What is that? 36.72 volts. Similarly, what is alpha V? Minus 0.34%. These two values you pick up from your data sheet. Okay, you pick up. So put 0.72 minus into 1 plus minus 0.34 into 40 minus 25 divided by 100. So this value is minus 0.051. So how much it decreases? 34.847. You'll see here how much is decreased. How much is decreased? You'll see here. Let me go for it here. 0.72 minus 0.847. How much is decreased? 1.873 volts. See here. Here it decreased by 1 point decrease. 1.3 volts. Okay, this much is decreased. Decrease it by decrease by 1.873 volts. You can understood that what's happened here when the temperature increases, what's happened the output open circuit voltage decreases. But what about the short circuit current? Increases. See here. Change or increase it by. Change or increase it by. Okay. Here decrease it by 1.783 volts. Okay. Understood that. So next what's happened? So that they're explaining all these things in this case. All these things they're explained here. So we need to change in maximum power. What is the same formula? Here also you'll see that what is the delta P. So alpha P into PM at the 25 degrees centigrade delta T by 100. So PM will take the common 1 plus alpha P divided by delta. So here we need from data sheet, you need data sheet. What is the PM? 240 watts. And what is alpha P? Minus 0.47. So PM is 240 watts. Or no? And alpha P is minus 0.47. So then what's happened here? See here how much will be decreased in the power. 240 minus 240 should be equal to 70 watts. So decrease in much of power is decreased when temperature increases. So this is about. So you can understand that what's happened here. See here, decrease it by 17. So this is about how you are obtaining when you change the temperature. What's happened in case of current, open circuit voltage, and the maximum power. Can you understood that? So this is about these things. So that thing they are explained here. So the delta P value, alpha P, temperature, and so the portion will become as minus. Okay. So finally, I concluded that what's happened when the temperature increases, short circuit current increases, whereas open circuit voltage and maximum power will decrease, which it depends on temperature, how much of temperature increases. Okay. Thank you. All the best. God bless you.